In this lesson, we are going to look at actually solving a triangle. And what this means is we're going to determine the measures of all the angles and lengths of all the sides and angles in the triangle. When we calculate the measure of all the angles and all the lengths in a right triangle, we solve the triangle. We can use any of the three primary trigonometric ratios to do this. So there are your three ratios. We also could look at using Pythagorean theorem as well, once you know two of the three sides. There is a little method of trying to remember these formulas, and it's called SOHCAHTOA. So get used to saying SOHCAHTOA, SOHCAHTOA. What this does, this phrase gives you all of your three trig ratios. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Say it over and over and over again. Ask your parents if they remember hearing SOHCAHTOA. What this is, here's your sine ratio. Here is what goes in the numerator, and here is what goes in the denominator. So sine equals opposite over hypotenuse. So, ka, there's your cosine. Here's your numerator. Here's your denominator. Cosine is adjacent over hypotenuse. Toa, here's your tan. Here's your numerator. Here's your denominator. So if you can remember SOHCAHTOA, you can remember all three of these trig ratios. We want to solve this triangle, and we want to give the measures to the nearest tenth when necessary. So we can start in many different places. It really doesn't matter. What we might want to do is we know two of the angle measures. So we could look at finding the third angle measure. What do we know about the sum of all angles in a triangle? We should remember that they add up to 180. So before I begin, I'm going to write down the 6 pieces of information we need to find. We need to know what angle E is, what angle F is, and what angle D is. We want to determine the sides of DF, DE, and EF. What do we already know? We know angle E is 25, we know angle F is 90, and we know side DF is 5. So we can find angle D by going 180 minus 90 minus 25. And what we will end up with is 65 degrees. So we found one other piece of our puzzle. So now we need to find a missing side. And it doesn't matter whether you start with DE or EF. You pick one, and it will vary in what ratio you decide to use. So let's choose to find DE. Now again, it doesn't matter which of the angle measures you choose. I would maybe recommend choosing the angle that is given to you, just in case you made a really silly addition or subtraction mistake and got the other angle incorrect. Then it's going to make your whole problem incorrect. So if we use the 25, what we have an opposite. Here's our right angle, so this is our hypotenuse. So which ratio uses opposite and hypotenuse? SOHCAHTOA. So, S-O-H. Sine of an angle is opposite over hypotenuse. The angle measure we were dealing with was the 25. Our opposite side is 5. Our hypotenuse is what we are looking for. Make sure your calculator is in degree mode and find sine 25. So we have 0.4226 equals 5 over x. Now let's solve for x. So we multiply both sides by the denominator. The x's will cancel out. We'll have 0.4226x equals 5. Divide by 0.4226. and we get x is 11.8, and we're going to the nearest tenth. So what we just found was side DE. It's 11.8. Now we need to find our last side, and we have multiple ways we could find this. We could find it using one of the trig ratios. We could find it using Pythagorean theorem, because we now know 2 of the 3 sides. There's no right or wrong answer. You can choose one of the methods. I personally, to find the least amount of errors possible, I like to go back and look at what is some of the original information given. That way, if I did make a mistake in one of my other calculations, it's not going to affect this other answer. Because if we did use Pythagorean theorem, and let's say we had calculated DE incorrectly, now we are guaranteed to get EF incorrect. So I always like to go back to the original information given. But you can use other methods. So here what we're now looking for is side FE. So from angle 25, we go across, we have our opposite side. Beside is our adjacent. So which ratio uses opposite and adjacent? So, ka, toa. Toa. Tan. Tan theta is opposite over adjacent. We know our angle is 25. Our opposite side is 5. Our adjacent side is x. Use your calculator, making sure it's in degree mode. Find tan of 25. 0.4663 equals 5 over x. Multiply both sides by x so that the x's cancel out. We have 0.4663, x equals 5. Divide by the 0.4663. And we get x equals 10.7. So EF is 10.7. And you would have got that answer had you used Pythagorean theorem because we have correct work. You would have got that answer had we used the fact that this angle is 65. You could have used opposite over adjacent. So we could have gone that way as well. We also had already found out that this was 11.8. So we could have used one of the other ratios. Had we chosen 25, we could have used adjacent over hypotenuse. So we could have used cos. There's lots of different possibilities. The key is finding all of the sides when it asks you to solve a triangle. So now we have multiple triangles. We have more than one. From a height of 50 meters in a fire tower, a ranger observes the beginnings of 2 fires. One fire is due west at an angle of depression of 9 degrees. The other fire is due east at an angle of depression of 7 degrees. What is the distance between the 2 fires to the nearest meter? So what we are looking for is this distance. But we're not going to be able to find it in one step. What we are going to have to do is we are going to first of all have to find this distance in the first triangle. And then we are going to have to find this distance in the second triangle. And then we can add them together. So if we're looking at the first triangle, again, the angle of depression is not in the triangle. So we can do one of 2 things. We can either recognize that this angle down here is going to be 9, or we can use the fact that this is a 90-degree angle, and 90 minus 9 is 81. It really doesn't matter. We have our one side being 50. So what we are looking for, here's our right angle. So if we chose to work off of the 81 degrees, we have our opposite side and we have our adjacent side. So think back to your ratios. So, ka, toa. Tangent is opposite over adjacent. So we're going to have tan of 81. The opposite side is what we're looking for. The adjacent side is 50. So use your calculator, make sure it's in degree mode. Tan of 81 is 6.3138 equals x over 50. Multiply both sides by 50. And we get 315.69 equals x. We're looking at the nearest meter, but because this isn't our final answer, we will leave it with the decimals so that when we combine the two distances, we are as close to the nearest meter as possible. So now we need to repeat this process with the triangle on the right-hand side. We've got our 7-degree angle of depression, so that means it's 7 in this corner, or 90 minus 7 is 83. Now just to show you it can work from either angle, because we chose the 81 on the left-hand triangle, I'm going to work off of the 7-degree measure in this one. So what we have, here is our right angle. So we have our adjacent side and our opposite. So we're still using our tan ratio. So we've got the tan of 7. Our opposite side is 50. Our adjacent side is y. So we need to solve this now. So the tan of 7 is 0.1228 equals 50 over y. Multiply both sides by y so that the y's cancel out. We have 0.1228y equals 50. And then divide by 0.1228. And we get y equals 407.17. So now if we add these together, we get 722.86. To the nearest meter would be 723 meters. So that's how far apart the fires are. So in solving triangles means find all missing parts. And then in this example, sometimes you have more than one triangle in your diagram, and you need to solve each part individually and then maybe put some numbers together. Or sometimes maybe you have to solve in one triangle to find a side that happens to be in the second triangle so that you get to the information that is necessary.